Hello everyone from Math 1340 Statistics. It's Professor Wenson here again. In this video going over section 2.1 called stem and leaf graphs or stem plots, line graphs, and bar graphs. Alright, so now I'm in the canvas here in teacher mode. So you're not going to be seeing this just yet. You'll see something different, the week 2 module, but the module will be pretty similar. And you'll have a page for section 2.1. Open that up. And it's just like every other page for the sections. You have a read, section 2.1 of your OpenStax book, and again a link to the book. Click on the link. It should open up openstax.org and take you right to section 2.1 in the statistics book. And read it just like any other textbook. Pay attention to bolded words, read through the paragraphs, read definitions, read the examples, and there are some, you've seen in other sections, there are some examples where it has, show solution at the bottom. I would recommend you try doing examples on your own first before seeing the solutions, and then see how you did. And ones where you try things out on your own, I recommend doing those as well. And yeah, let's read through section 2.1, please. Alright, then below that you have what I'm going to get into in a little bit, going over the KnewtonAlta homework. There's a link to that here, section 2.1 KnewtonAlta homework. And then beneath that you have watch some videos. Now if you don't like these videos, you can always just, copy the objective and paste it into YouTube and try to find other videos related to the topic that you like better. So I have the objectives from the KnewtonAlta homework, and at least one video beneath it. Now you can play the video in Canvas. This one's actually playing. Alright, you can play the video in Canvas, or just click on the link and open up the YouTube page with that video on it. Whatever you feel. Alright, and there's objective video. There's five objectives in this assignment. Alright, so I'm just going to go straight to the KnewtonAlta homework. Click on this and it'll have me open it in a new tab. Open it in a new window. Again, I'm in teacher mode here, so what I see is not going to be what you see. I'll show you what it looks like as a student. All right. So preview as student, and you've hopefully by now seen sections 1.1 through 1.4, so you know what to expect these to look like. You have the title of the assignment up here, right? You're not going to see the word preview. Your mastery bar showing you how much you've completed. Current objective for the question below. Then you can click on the down arrow and see all the objectives and the progress you've made on these objectives, right? And what particular. Now don't worry about the numbers so much, right? This is section 2.1. These are all topics from KnewtonAlta that are related to section 2.1 from your OpenStax book. That's how I've organized it. So you got 5 objectives. Looks like 1, 2, 3, 4, 5. Right? And the progress and an estimated number of questions. Remember, the more you get incorrect, the more questions you'll get. So don't guess on things. Alright, so this first question here is on the objective, create and interpret stem and leaf plots, also known as stem and leaf graphs or stem plots. Now, being that it's the first time I'm seeing this objective, now again, if you have read through the material, you read the OpenStax book, you watched some videos, and you feel comfortable with the material, go ahead and start answering questions right now. But if you're still uncomfortable with the material, or the title of the objective still doesn't make sense, I'd recommend every time you see a new objective or come across a problem you're having troubles with, click on More Instruction. You're not going to have the instructor cheat button, right? But you'll have more instruction and get through the assignment this way. Right? View instruction. All right. So stem and leaf plots. Stem and leaf plots are a graphical method that uses the actual data values themselves to create a graph. An advantage of a stem and leaf plot is that once the plot is created, the original data set can be recreated from the plot, since the data values themselves are evident, right? Meaning you can see the actual data in the graph. The shape of a distribution can be determined since the stem and leaf plot can be considered as similar to a dot plot or a histogram. We'll see what a histogram is in a later section. But basically, what they're saying here is that these stem and leaf plots look kind of like bar graphs, right? A histogram is a type of bar graph, but instead of bars, you have stacks of numbers. The heights of the leaves can be viewed in a similar way as the height of the stacked dots in a dot plot, and in a similar way to the height of the bars, right? I mentioned bars in a histogram. A histogram is a type of bar graph. Now you can watch this video. I'm not going to watch a video within my video, and then some key terms, right? Which I've already read. Right, so I hit continue and it takes me to a question. Alright, now I'm going to write this out and show you what this means, how you can interpret, recreate the data set using this. This is called a stem and leaf plot right here. You see the stem column, leaf column. So I'm going to go to a piece of paper and show you how this was created. Alright, so the data below contain the number of counties in a number of U.S. states in 2013. The data are summarized by the stem and leaf plot below. Okay. So I've written out here the stem and leaf plot you just saw. So stems are usually all the digits of a data value before the final digit. So before last digit. And the leaves, right, all these numbers over here, will represent the final digit of some data value, or the last digits of the data. Right. So from this stem and leaf plot, we can recreate the data set. So when I see this stem of 0 leaf with a leaf of 0, this means that the number 0, right, 0, 0, right, it's all zeros, was in the data. So that, one state had 0 counties. So that could be like, I think Rhode Island doesn't have any counties, or Hawaii. Don't quote me on this, but or maybe even Louisiana. Right? Louisiana, they don't have counties. They have what are called parishes, which are like counties. But so I have 1, 0, right, 0, 0, another 0, 0. So another 0 is in the data set. A 0, 3, meaning 3 is in the data set. A 0, 5, meaning 5 is in the data set. Another 0, 5, right? 0, 5. And 0, 8. So 8 is in the data set. Alright, so here's some values from, that's what this first row is telling me, that the values 0, 0, 3, 5, 8, 5, and 8 are in the original set of data before this graph was made, this stem and leaf plot. Then the second row, you have a stem of 1, and then all these leaves, all these digits, and you see how they're stacked up so that things are lined up, so you can see that, oh, there were 6 values starting with nothing, starting with 0, and there are 6 values of the data starting with the number 1, so an equal amount. Right? And having a stem of 1 and a leaf of 0 means that the value 10 So one of the states they looked at had 10 counties. Then one with 4, meaning one of the values in the data set was 14. One with 4 again, 14. One with 5, 15. One then 6, 16. And one then 6 again, so 16. So here are some 6 other values in the original data set. Then for the last row, there's only 4 values in the data set that started with a 2 and ended with 1, 3, 3, and 9. So 21, right, 2 and 1. 23, one state had 23 counties, another state had 23 counties, and another state had 29 counties. Right. So this right here that I'm putting in this box would have been the original set of data. And what they did was they took this, you take this original set of data and make what's called a stem and leaf plot, where again the stem is all the digits before the final digit. All right, all the digits before. So all these have a stem of 0, as you see. And then 1, 1, 1, 1, 1, 1. So there's stems of 1. There are some stems of 0, stems of 1. There are some stems of 2. Right? And if there was a 30 or something, right? I'm just making this up. This isn't part of the thing. But if there were another value in here, say 38, stem of 3, so I'd add to this. There's a stem of something with a stem of 3, and then the leaves are the final digits, right? The leaves are the last digits. You have a leaf of 8. So that tells me that 38 is a data value. And the leaves are typically written in numerical order. You see how it's going from lower to higher, 0 to 8, then 0 to 6, 1 to 9, 8. Same for the stems down the stem column. Usually, these are written in least to greatest. And the leaves are also lined up and stacked up so that it looks like, if I were to turn it this way, you can see which stems had more values in it. Right? It's almost like the heights of bars in a bar graph. Right? If you think of this as a bar, and then this is a bar, and then this is a bar, right? You can see that there are more values in the data set with a stem of 0 than there are with a stem of 2. Right? Okay, but usually we don't look at it this way. You can very easily look at it, the regular way and see the same stuff. All right, so hopefully that was clear. Now going back, let's answer their question. All right, so now which of the following statements are true? And it says select all that apply. All right, so possibly multiple answers here. There are 5 states in the data set with greater than or equal to 10 counties and less than or equal to 19 counties. So if you're greater than or equal to 10 and less than or equal to 19, well, that's 10 to 19. That's going to have a stem of 1. That's this row here. You saw 10 when I wrote out the data set. It was 10, 14, 14, 15, 16, 16. That's 6. You just count the leaves. There were six states with, greater than or equal to 10, less than or equal to 19. So that's false. It says there are 5 states, but we see 6. There are 4 states, basically from 20 to 29 counties, which, count the leaves on the stem of 2, 21, 23, 23, 29. There's 4 states, 4 numbers from 20 to 29. There are 11 values in this data set. Well, let's see, there were 6 from the first row, 6 leaves. The number of leaves is the number of values in the data set. There were 6, 6, and 4. That's 16, not 11, which makes this last statement true. There are 16 values in the data set. All right, so again, hopefully you saw on my paper how I made the data set from this, right? Just basically the number of leaves is the number of values you're going to have in your data set. Okay, so good, I got that one. Read the explanation and all that, please, right? Okay, so it looks like I'm still in the same objective. I'm out of the more instruction now. All right. And again, a set of data is summarized by, here's another stem and leaf plot. So remember what this means. This means there, the first row here means there's values of 13, 13, 14, 15, 16, 17, 18, 19, and 19. And then the second row, 22, 24, 26, 27, and so on. So hopefully you can know how to read these now. Alright, so provide your answer below. Look at some fill in the blanks here. There are blank values in the data set which are greater than or equal to 30 and less than or equal to 39. So in the 30s. So go to the 30s, there's 31, 34, 38, 39, 39. There are, just count the leaves. There are 5 values in the 30s. And there are blank values in the teens, right, from 10 to 19. That's the first row. Count the leaves. I said it already. 13, 13, 14, 15, 16, 17, 18, 19, and 19. That is 9 values, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 values in the teens. Wonderful. All right, pretty easy to read. I hope that's pretty easy to get through. Stuff like that when you're given a stem and leaf plot and asked for some information. All right, looks like I got another one. I'm working my way through. Now, again, what I see isn't going to be the exact same order that you see things in. So when you're watching my video and using it as a guide to go through your assignment, just pay attention to what objective I'm on. All right, and you're going to see different problems in different orders, but the objective, the instruction, the way you do things is all the same. So there's another stem and leaf plot for some set of data. There are blank in the 20s. 21, 21, 22, 23, 23, 24, 28, 29. Count the leaves. There are 8 of those, right? 8 values in the 20s. There are how many values in the 10s? 11, 13, 15, 16, 16, 17. That's 6 leaves there, 6 values in the 10s. How many values in the 40s? 41, 41, 41, 42, 42, 43, 43, 44, 45, 46, 47, 47, 47, 47. Alright, so that's what? 5, 10, 14 values in the 40s there. And just going to pay attention to the count. Count, make sure you're counting correctly. And again, read the explanations when you're done to help you out. Alright, still in the same objective. Alright, again, it might if you might jump from objective to objective in your assignment. Another stem and leaf plot. Now, let me point out one thing. Stems don't have to be a single digit. Stems can be multiple digits, right? It's the leaves that are a single digit. Right? The leaves are always just the last digit. Stems are made up of everything before the last digit, right? So, in all these examples, the stem was a single digit. Just know that that's not always the case. All right, so how many values are in the 20s, right? From 20 to 29, there's 6 of them, right? 21, 22, 26, 28, 29, 29. 6 of those. And how many values in the 10s? The rest, right? There's 11, 11, 12, 12, 13, 13, 14, 14, 16, 16, 17, 17, 18, and 19. That's, let's see, that's 6 we know. And then 3, 6, 8, say that's 14 values in the 10s. Wonderful. All right. Pretty easy, I think. You saw those problems are pretty simple, those stem and leaf, just how to read a stem and leaf graph. Alright, so the next objective that pops up on me is create and interpret line graphs of data. Alright, so let me go to the more instruction. It's the first time I'm seeing this. Alright, so line graphs. Hey, James. Alright, that's my name. I don't know who made this video, but so line graphs. Now there's a video here. Some key terms. Making a line graph, I'll just point out on this thing here, is kind of like, you have a you plot points. You plot points and connect those points by lines, without the bars. Ignore the bars are a bar graph. You're just plotting points on a graph and connecting the bars, right? I mean, you could also have the bar in there, right, to determine show you the heights, right? This is also considered a line graph, I guess. All right, so let's read the key terms at least. All right, I'm not going to watch the video. You can do that. Line graph. A bar graph with the tops of the bars represented by points joined by lines. So it kind of tells you the trends, right? It shows you the trends. So a bar graph is simply, you just count how many are, you can do it for categories, like here, income on Mondays, almost $600, and Tuesday almost 400, Wednesday almost 200, Thursday almost 900, whatever. And then connecting the tops of these bars with lines here and dots shows you like the trend, how things are trending. With the rest of the bar not shown. See, I did think that, right? The bars shouldn't be shown, and are only appropriate for ordered rather than qualitative variables that show how a quantity changes over time. Right? You see how time passes here, right? Something with some sort of order involved. A line graph may also be referred to as a line chart or a time series graph, right? And time series data is data that shows how a quantity changes over time, best displayed graphically with a line graph. All right. So I continue, and it gives me a question. All right. Now here's an example of a line graph, right, with no bars here, but you could imagine bars underneath if you want. Horace is trying to improve at golf, and so he keeps track of the number of total rounds he has played over time. Time series data, right? The line graph below shows the data. So like 0 weeks in, during that first week, or in the 0th week, the week he starts, he plays 1 round of golf. Put a dot. Then the first week after he starts, he plays 3 rounds of golf. Put a dot at the 3. You see the rounds played. It's weeks time on the bottom versus rounds played at the top. Second week, 4 rounds of golf. Third week, 9 rounds. Fourth week, 10. Fifth week, 12. And sixth week, 13. Now, if you've been in an algebra class, you've plotted points on a graph before. You have a horizontal axis, vertical axis. You plot ordered pairs, and it's kind of similar here. You'd be plotting points on a graph, and then just connecting them with these segments to show how things are trending over time. So how many rounds did Horace play from week 1 to week 3? Right, so don't include the unit. Don't write the word rounds basically in your answer. Just put the number. So from week 1, so I'll start at 1, to week 3, end at 3. That was 3 rounds plus 4 rounds, so 7 rounds total, plus 9. That's 16 rounds from week 1 to week 3. 3 plus 4 plus 9. Played 16 rounds of golf in those particular weeks. Oh, did I add Ron? All right, let's see what the answer. All right, so now it's going to see this will happen from week 1 to week 3. 3 plus 4 plus 9. That's 16. Let's see what their answer is. 6. Oh. Okay. Okay. I misread the table. Alright, my apologies. This will just make it a little longer. Yeah, he keeps track of the number of total rounds. I misread that. I thought this was the number of rounds he played each week. But this is each of these is the total rounds he's played up to that point. So when he starts off, he plays a round. Then a week later, he's played 3 rounds total, from week 0 to 1, and then week 1 to 2 he played a total of 4 rounds. So he only played 1 round in that week to go from 3 to 4. That makes sense when reading the word total here. When this is, see, they should have put in the total rounds played on the side, because that's what's mentioned up here, but whatever. Then from week 2 to 3 went from four rounds total to 9 rounds. So he played 5 more from weeks 2 to 3. So from week 1 to 2 he played 1 round, and then 5 more from 2 to 3. So that would be the six total rounds. All right, so again, please, here's a lesson for you. Read carefully. I did not. I rushed through that. I apologize. So that'll add to the length of this, right? When you get things incorrect, it'll just throw more questions at you. All right. So here, Russell started out on a road trip at noon and drove until 8 p.m. The data listed below represent the total total cumulative distance. So I'm keeping that in mind. Right? He drove in miles over 8 hours. Alright, so they're asking us to create the corresponding. Now you can do this by hand. You could draw by hand if you wished. So if I were doing this by hand, let me show you real quick. I'm not going to do the whole chart, but if I were drawing this out by hand, there was a. Oh, that's terrible. Okay, here we go. Nice dark marker here. We'd have time and hours in the bottom here, time passing. And then over here, now they said total miles driven in the problem. Miles driven. So at time 0, at the beginning it was 0 miles, there'd be a point there, a dot there. And then it says that, 1 hour later, I'm going to put some notches here, say this is 20, 40, 60, 80, and so on. Make sure it's, if you were making it by hand, you would, try to make sure things were evenly spaced. And, it says 1 hour later, he'd driven 52 miles, so maybe somewhere in here. There's about 52. Then and this will be the last one I put up, then you have 100 and 120, and then they said 2 hours later, he'd driven 120 total miles. So we have this, and then this, and again, I'd go 3 hours and how many total miles and so on, and create and finish the line graph like that. If you were doing it by hand. All right, but in this exercise, this is one of the interactive exercises where you're asked to move some points around. So you got to click on a point and move it. So again, 0, 0. So 0, move this down to the point 0, 0. Very, very sensitive. There we go. Then 1 hour later, 52 miles were driven. So it's 150. All right, move this down to 52. And again, pretty sensitive. Oh geez, it moved on me. Pretty sensitive this. Oh my goodness. Alright, I'm going to play around with this and come back when I'm done. Okay, so I have now dragged all the dots here to their respective points, right? So you got, see, 8 hours later, driven a total of 414 miles. 7 hours, he's driven a total of 356, and so on from the chart. Yeah, that's a bit of a pain. I apologize for that, but hey, it's not that difficult a problem. It's just it's pretty sensitive to movement. So just be diligent, and you can get through it. And that's all we were asked to do, is make that line graph, right? So it hits it. Oh, what did I mess up on? Oh man, it moved my 0 back down to 0, 1. I thought I had it. There it is, 0, 0. Submit. There we go. And try it again. Great. Yeah. See, I think I bumped it a little bit and didn't pay attention the rest of the time. So it's pretty sensitive, this, but you can get through it. Okay, moving on. So again, still a question related to the same objective, right? Making these line charts, line graphs. So according to the information above, which of the following is an appropriate analysis of the miles driven by Russell on his 8-hour road trip? So again, looking at this chart I just made on his, 8 hours later, he had driven 414 miles from his starting point. So from the data, let's read which one makes sense. From the data, when the number of hours increased from 0 to 1, the total number of miles driven increased by 1? No, it increased by 52, so that's not true. From the data, when the number of hours increased from 0 to 3, the total number of miles driven increased by 55. Well, from 0 to 3, it went up by 175, so no. From 2 to 3, the total number of miles increased by 55. So from 2 to 3, yeah, he had driven 120 miles after 2 hours, got to 175 miles an hour later. From 2 to 3, that is an increase of 55 miles. So in that 2 to 3 hour mark, in that hour, he drove 55 miles. So this is correct. Number 3 there. Wonderful. So back to, so we're still on the objective. Oh, move. All right, so here's a new one. There's a new one. All right, no progress made. Create and interpret these. These are bar graphs. All right. So again, first time I'm seeing it, I'll click on More Instruction. And what are bar graphs? Now, there's just a video. Now, yeah, bar graphs are simple, I feel. You have your usually it's categories listed, and then the bars, the heights of the bars represent frequency, how many are in that category. And you try to, have the bars be the same width and all that, and maybe even draw them different colors and whatnot. But, you can watch that video there. And key terms, a bar graph is a graph to summarize and organize categorical data, right? That's qualitative data, consisting of rectangular bars that are separated from each other. They could be connected as well. They don't have to be separate. But when they're connected, we'll see that that's called a histogram. But they can be connected as well. And the length or height of the bar for each category is proportional to the number of percent or individuals in the category. Right? So the height of the bar could be a percentage, what percentage of the data is in that category, or it could just be a frequency, how many individuals are in that category. A bar graph may also be referred to as a bar chart. Okay. All right, so here we're given a bar graph, right, where you see the bar graph below shows the number of men and women in the chess and math clubs. Now pay attention to your legends, right? What things mean. Blue bars represent men, red represent women. So just reading this, right, you see you got clubs down here, the categories, right, your categorical data, clubs, chess, math. Then up top here you have a numerical axis with evenly spaced numbers starting at 0, and its number of students in those clubs. So again, blue is for men, so it looks like there are 14, the height of the bar, 14 men in the chess club. Looks like there are 15 men in the math club. And red is for women, right? Looks like there are 17 women in the chess club, and look at where this is. This is 11 women in the math club. Just reading that pretty quickly. What is the total number? Again, total coming up. Total number of women across both clubs shown. And don't write the units. Don't write the word women. Right? Just write the number. So it says, what's the total number of women in both clubs? So I said earlier, look at red for women here. There are 17 in the chess and 11 in the math. 17 plus 11 is 28. There are 28 total women, right? Just looking at the red bars. And wonderful. All right, so pretty easy to interpret, I think, right? Especially when you're given one. And it wouldn't be very difficult to make one either. Right? You just write the category down on the horizontal axis and make a bar, and the height of the bar is just how many people are in that club, or how many people are in that category. Could also, again, this axis with the numbers could also be percentages, what percentage of the people are in these clubs, but here it's just a count. All right, so this one I'm going to make one. Now, if I were asked, it's one of those where you have to slide little dots around and make bars. But I'm going to start off. I'll start making it by hand and show you what you would do to make a bar graph by hand. A local cafe recorded the beverages their customers ordered on a particular morning. The following table shows the items ordered. All right, so you have item ordered and frequency. All right, so if I were making this by hand, I'd have that's not bad. Little two axes here. Down here, items ordered was one column, and you had drip coffee. I'll just do the first couple. I'm not doing the whole thing. Drip coffee was one of them. Then decaf coffee. One more here, and a latte. And I'm trying to make these evenly spaced and stuff, and so on. There were two more. Hot tea and a smoothie. Might as well just write them all. Hot tea and a smoothie. And then on the vertical axis was frequency. How many? Right? How many did they order? How many people ordered drip coffee? And again, starting down here, start at 0 and evenly spaced numbers. Now based on the numbers there, maybe I'll go every 10. And again, things are evenly spaced as I can make them by hand here. And then I said drip coffee. 56 people, right? 56 people ordered drip coffee. So I make a bar that's over the drip coffee here, where drip coffee little markers in the middle of the bar, and this is 56 high. 56 high. Maybe even color it in or something if you have a different color or whatnot. Decaf 25. So I go 25 here. Make a bar over the decaf that's 25 high, and so on. Right? I would do the same for the other three. That's how you would draw a bar graph by hand. But like last time, this is one of those drag the dots interactive one. So drip coffee 56, and just as before, it's pretty sensitive. 56. There we go. Stop. Great. All right. And then decaf 25. Right. 25. Yeah, make sure 24, 25. Stop. All right. Lattes. 38 people ordered a latte. So I drag that up to 37, 38. Good. 12 people ordered a hot tea. There we go. And 16 people ordered a smoothie. There, stop. All right. There's a perfectly good bar graph or bar chart representing the information given on this table. Right? And it's a very nice way to see information, right? And you can very clearly see who ordered more than what category was ordered more than other categories. And I'm sure they'll ask a question afterwards about this bar graph. Alright, so answer explanation, cool. And continue. And then look, which cafe beverage was ordered the most? Well, clearly, the drip coffee. Right, and I know you could have told that from the chart as well. I mean, you could have just looked at the numbers, but it's easy to tell when it's in a bar form. Right? drip coffee. And they might ask some other question, right? Which was ordered least or whatever. All right, so create and interpret bar graphs still. So there's another one. Again, another one that's pretty. It's like this is just like that chess and math club one, only it's the bar graph shows the number of men and women in different groups in band and orchestra. Again, blue represents men, red represents women. Question this time is, what is the total number of men across all the groups shown? And don't write the word men, right? Don't include units. So men is the blue bar. So there are how many in band? How many men in band? 13. And how many men in orchestra? 16. 13 plus 16, 29 total men represented by this bar graph. All right, so 2 of the 5 objectives, wonderful. All right, back to line graphs. All right, so here's a line graph that was given. Now this is similar to other ones we've seen. Right? As weeks pass, how many movies were watched, and this is the total number of movies. It looks like, yeah, Mark is keeping track of the total number of movies he watched over time. Line graph below shows the data where the number of movies corresponds to the number of movies that had been watched at the beginning of the week, shown on the horizontal axis. So at the beginning he's had watched no movies. A week later he's watched 2. 2 weeks later he's in the first 2 weeks he's watched 6 movies. So that means from week 1 to week 2 he watched 4 movies. And then 3 weeks, since the beginning he's watched 7, then 8 after 4 weeks, 9 after 5 weeks. Right? How many movies did Mark watch between the beginning of week 1 and the beginning of week 5? And don't write the word movies, right? Don't include units. So at the beginning of week 1 he'd watched 2 movies. Beginning of week 5 he'd watched 9 movies. 2 movies to 9 movies, so he'd watched 7 movies over those weeks. Put 7 there. Wonderful. Fantastic. All right. So it's got 2 more objectives. Now these are the same stuff, right? Line graphs and bar graphs. But how do I make a line graph or a bar graph, a bar chart on my TI calculator, TI 8384? Now what I'm going to show you is on the 84 plus, but it's very similar on the 83. All right. So again, I haven't seen anything like this yet. I haven't seen this objective, so I'm going to click on more instruction, view instruction here, and it takes you how to create these things on your calculator, a little how-to. So the first one's how to create a line graph with your TI-84. So you make a list. You enter lists of data, list 1 and list 2. One will be for a horizontal axis values, and the other list will be for the vertical axis values. And you go to the stat plot and follow these steps, and I'll show you these steps when we get to a problem. All right, I'll actually pull it up on paper. And then here's how to create a bar graph on your TI-84. Now this is only going to be entering one list of data and then going to stat plot and creating a bar graph. All right, and like I said, I'll show you here. All right. So here's one that's going to be creating a line graph. All right, I see a line graph. So let me show you how to create a line graph with this data. So I'm going to go to a piece of paper. I'll have this written out, and I'll show you on paper and calculator how to make a line graph on your TI calculator. Alright, so here's that same table, alright, where each week and how much snow fell in that week. So 1 inch fell in week 1, 2 inches in week 2, 19 inches in week 3, yikes, and so on. I'm going to pull up here's my TI-84 Plus Silver Edition. What I do here is very similar to what you can do in the TI-83. So if you have 80, and that's the instructions that you're seeing in KnewtonAlta is with the TI-84 or 83. Alright, so how do I enter this stuff in my calculator? So obviously first turn it on, and then to enter a list of data, alright, you hit the Stat button. Now I've shown you how to enter a list of data before. Here we're going to enter two lists. Alright, two lists of data, one for the week numbers, one for the snowfall in inches. So I go to hit Edit. Then you see List 1, List 2, L1, L2. So down List 1, I'm going to enter the numbers, the week numbers. This first, the week numbers, 1 through 10. So 1 enter, 2 enter, 3, 4, 5, 6, 7, 8, 9, and 10. Alright, and then I move my cursor over to list 2 and write the corresponding, enter the snowfall list. Right? The snowfall in inches. So first week 1 inch, second week 2 inches, third week 19 inches, fourth week 4 inches, fifth week 17 inches, then 22, 10, 3, 2, and 11. Alright. So I've got my 10 rows entered, both lists. Alright, then I get out of here, or quit, and then above the Y equals button, you'll see it says Stat Plot. I'm going to have to hit second, then the Y equals button, and you see Stat Plots. I'll just enter on number 1 there, and hit enter on, turn it on, actually graph it, and scroll down, and you see the type. I'm making what's, a line graph. That's the second type. Alright, so the first type is just a bunch of dots. The second type has connected dots. So I go enter on that second type. And then scroll down where it says X list, this is for your horizontal axis, which is going to be our weeks. And that was in list 1. Now it's already L1 here. But if you want to enter list 1, you just hit second and the number 1, and you see how L1 is above the number 1 on the keypad. And then the Y list is for the vertical axis, the up and down, and that'll be my snowfall in inches. Now that was in list 2, right? And it's already there, L2. But if you want to enter list 2, you just go second and then the number 2 for L2. This mark stuff is just what do the dots look like. Do you want them looking like little squares or little plus signs? So this really doesn't matter. Alright. So then I'm going to hit, to get the graph that I want to actually show up on my window, I'm just going to now hit zoom. And then you can scroll down to number 9 or just hit the number 9. But number 9 is zoom stat. Remember that was called a stat plot. When you hit zoom stat, it'll zoom in and show you a graph. It'll change the window for you so that all your statistical plots will show up on the same graph. And there you go. There is a line graph of this data. Right? And if you'd like to see what these points are, you can hit the trace button, hit trace, and you see the first one, 1, 1, right? In the first week, there was 1 inch of snowfall. Then just move along the graph with the cursors left and right. See X is 2, Y is 2. That's this second row. 319, the third row, right? 319. 4, 4, 5, 17, 6, and see how it's flashing on the point that you're at. So you can move along the graph like this with the trace button. All right, so that's how you make a line graph on your calculator. And they go through the same thing here. Right, and you see the same exact picture that I showed you just now. All right, now how do you make a bar graph on your calculator? So I'm going to do the same thing where I'll write this out and I'll show you how to make a bar graph on your calculator. So here we have a meteorologist would like to study the number of days with precipitation in each month in a city for 1 year. So days of precipitation. Alright, so in January for this particular city there were 11 days where there was precipitation, rain, snow, sleet, hail, In February there were 7 days with precipitation, March there were 9 days, and so on. So I'm going to make a bar graph, right? Again, where the categories will be my horizontal axis and then the numbers, right, either percentages or numbers, here it's just numbers again, are the vertical axis, and the height of the bars will be the representing of the frequencies, the number of days with precipitation. All right, so I'll do this on the calculator as well. Okay, so here I am. This is the same table just written out where I have, the month and then the number of days in that month that had precipitation. All right, now when you're making a bar graph on your calculator, you're only going to need to enter one list. All right, because one list will be categories, category 1, category 2. You don't enter the categories into a list in your calculator. You only enter numerical variables, right? And categories aren't quantitative, right? So I'm going to be entering this list and this list only, right? The number of days, but in that order, right? In that order. So I have the months in the correct order. So on the calculator, again, to enter a list of data, I hit Stat, go to Edit. Now, if you want to clear your lists, like I've already done that, but if you want to clear your lists, you just move the cursor up to where it says the list name, hit Enter, make sure it's flashing, and then Clear, and then Enter, and your list should be empty. All right, I've already done this. So down list 1 again, L1, or you could have just done down L3, a new list, but I'll do it down L1. I'm going to enter these numbers of days of precipitation. Right, so in the first month there were 11 days. Right, in February there were 7. Then in March there were 9 days of precipitation. Then 11 in April, 10 in May, 12 in June, 7 in July, 12 in August, 11 in September, 9 in October, 11 in November. Oops, that's a 1. 11 in November, and 9 in December. Okay. And again, there should, look at, this is L1 number 12, right? There should be 12 of these. There's, 12 months of the year. All right, so now I've got all my my data entered, right? Again, not the categories. And I get out of here, and just like I made my line chart, my line graph, I go second, stat plot above the y equals. Go to plot 1 or plot 2 if you want. Make sure it's on so that you see a graph. And then what type of graph? Well, the third one, right? The second one is a line graph. The third one is a bar graph. You see the bars in it. And then, X list, L1. This is the list of data you just entered, which, was L1. If you want to, again, if you want to enter L1, let me move this down, L1, you hit second, L1, right? Frequency list. Now, the frequency list, if there's no frequency, we'll see later. Right now, each of these numbers in my list here is counted just one time, right? There's 11 counted once in the first row for January. February, 7 counted once. We'll see how, later when we're going to count pieces of data more than once, but for right now, keep frequency as 1, right? All right, then I'm going to make my graph. Go to zoom. Oops, I'm in second there. Let's quit that. All right, let's get out of there. Quit. Sorry. And I'm going to go zoom and just hit the number 9. 9 is that zoom stat that I showed you earlier. And there you go. Here's a bar graph. And I notice they're connected, but there's a bar graph. Oh, that is actually a terrible bar graph. Let me redo this so that you actually get 12 bars. Just a second. Okay, so this right here. I mean, if I hit trace right now, see what the issue is. This is where you have a min 7. Oh, okay. So this is this is just telling me how many months have certain numbers of days of precipitation. I see. So 7 days to 8, so this is 7, there are 2 months with 7 days, as you can see, February and July, right? 2 months with 7 days. So this is a little weird, this bar graph. Yeah, if I were to make a bar graph by hand, it would look a little different. There is a difference here between the calculator and the hand graph. If I move over, so this is 8 to 9, but less than 9, so 8. How many have 8 days of precipitation? 0, right? See, none of these have 8 days. So how to read this bar graph is a little different. 9 to 10, how many, but less than 10, so how many have 9 days of precipitation? 3, right? That was March, October, and December, right? How many had 10 days of precipitation? 1, right? 1 month, May, had 10 days. How many had 11 days, right? 11 but less than 12, so just 11. 4 months had 11, right? January, April, September, and November. And then the last one, how many had 12 days of precipitation? 2 of them, right? June and August. So the bar graph you're going to get on your calculator, you're going to interpret it in a little different way. It'll give you how many categories have that particular number of values. Because if I were making this by hand, let me get rid of this calculator bar here. Because if I were making a bar graph for this by hand, I'd probably make it this way: January, then February, then March, right, and so on. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, here's 12, and it's going by ones. And then January has 11, right, and then February has 7. Right, 7, and then March 9 days, right, and so on. That's how I typically make a bar graph. But your bar graphs on your calculator will tell you a different story. It'll tell you just how many, right? Well, that's what the n equals is here on the calculator. How many months or how many values, how many categories have a particular value. So again, 2 categories have 12. 2 months have 12, like June and August, right? So that's so how you interpret the bar graph on your calculator is going to be a little different. But still, it is a bar graph, right? It does demonstrate, show information. All right, and you're getting something similar here, right? Okay, so let's continue on and actually do some questions related to this. All right. So an online retailer tracks the weekly sales of a product over a 12-week period. The data are shown in the table below. All right, use a calculator to create a line graph representing the sales for each week. So I'll make a line graph. Right, and which one makes. Now you can work on the calculator, but look, it is multiple choice, so you can probably figure it out. Let's see. First one's 17 sales. Then the next two weeks 2 and 3 both have 21 sales. So the next 2 dots should be on the same level. So kind of like this one, and a little higher as well. 17 to 21 is a little higher. So like 17, 21, 21 looks like that first graph, and that's the only one that makes any sense, right? So I select that first one. Now again, let me show you one more time. I'll show you one more of each, but this time I'll skip through some things. But how do I make a line graph again? All right, so back to the paper. Now I've just got the calculator up, all right, and just give me a second here. I'm going to put up the chart that we had in the problem. Okay, so you see here I've written down that chart that was in the problem with the week number and how many sales were in that week, each week. On the calculator, again, you hit Stat, Edit, and I've already done this where I've put weeks 1 through 12 down list 1, and those sales numbers down list 2, right? You can enter those. All right, then I get out of here, go to the stat plot above y equals, enter on plot 1, turn it on, make sure that I'm on the second one here. I'm doing, I got 2 lists. I'm doing a line graph. Then list 1 for my x values, or whatever list you put the weeks in for the horizontal axis values. And then for the Y list or the vertical axis values, you know, whatever list you put sales in. All right, and then what do you want the mark to look like? It doesn't matter, right? So then I get out of here, I hit zoom, and then the number 9 for zoom stat, and there we go. And you see this looks like the graph that I selected, you know, here in the assignment, right? Part A there, and you know, it makes sense. Like I said, though, you know, if it's multiple choice like this, you can save some time by just kind of, you know, you can figure out what a line graph would look like probably pretty easily. All right, and then let's continue on here. All right, so this one's a bar. You know, see make a bar graph. A movie theater has a selection of 10 titles playing at one time. The number of screens for each title is as follows. So movie A is playing on one screen, movie B is playing on one screen, movie C is playing on 2 screens, etc. Create a bar graph, and then the question on the calculator. Now the question, again, if you want to save some time, you don't have to go to the calculator. You can answer this question using the table. You know, how many movies are being shown on more than one screen? So movie C is on 2, movie D is on 5, movie H is on 2, and movie J is on 3. That's four of them. 4 of these movies are being shown on more than one screen. So the answer is 4. I didn't need to make a bar graph. But again, let me show you how I would do this. You got your categories. Now you can't enter categories in a list, but you're going to enter the number of screens in a list. All right, so again, I'll show you how I would do that. All right, so this time I'll just pull the calculator up here. All right, so here it is. All right, so you go to Stat, Edit. I've already entered the list with the 10 numbers, you know, for the screens, right? The screen numbers 1125, 111, 213. All right, then I get out of there, go to the stat plot, plot 1. What type? I want to make a bar graph this time, so the third type. The X list is L1, and you know the frequency is 1, right? Everything's being counted once. So let's get out of here, go zoom, number 9. And now again, these there aren't 10 bars, right? There aren't 10 bars. How you're going to read the bar graphs on your calculator, it's going to give you numbers of how many categories have this number or that number. So I've hit the trace button. See, this is min 1 to less than 2. So 1. How many movies are being shown on one screen? 6 movies. See, n equals 6. 6 movies are being shown on one screen, which you see here, right? A, B, E, F, G, and I. That's 6 movies. So move the cursor, 2 to 3, but less than 3. So how many movies are being shown on 2 screens? 2 movies, right? Movie C and movie H. And then how many are being shown on 3 screens? 1 movie, right? That's movie J. How many are being shown on 4 screens? N equals 0. So you see, there's no 4s there. No movies are being shown on exactly 4 screens. And then how many movies are being shown on 5 screens? N equals 1. And you got 1 plus 0 plus 1 plus 2. That's like there are 4 movies being shown on more than one screen. All right, as you could have told me by just looking at the table. All right, 4 movies are shown on more than one screen. So like I said, very often with this assignment here, you can get past making the charts on your calculator and just do it in the assignment. All right, so this is line and bar graphs with technology again. All right, this time a doctor is reviewing the time it takes patients to recover from a cold using new medication. The doctor records the number of days taken for each patient to recover in a sample of 15 patients. The information is provided below. So you would make a bar graph, right? There's only one list of data here. And then how many patients need exactly 5 days to recover? Now you can do the bar graph, all right, which I'm going to do, and then I'll show you what it looks like on the calculator. Right. Okay, so I've done it on the calculator. I pulled it popped up on there real quick. Here's the bar graph I got, and entering this list of data here in one column, one list, and making a bar graph. All right, now when I hit trace on this, four of these patients had a recovery time of 1 day. 3 of them had a recovery time of 2 days. 1 had a recovery time of 3 days. They're asking how many patients need exactly 5 days to recover. So this bar here with the 5 to 6, 5 days. 3 patients needed exactly 5 days to recover. Now again, you could have just looked through the table here and said, hey, 5, 5, 5. There are 3 of them. I mean, you didn't need to take the time. You could have looked through here and said, counted 5, 5, 5. You could have counted the 5s without taking the time to enter, on your calculator and doing all that. All right. So this is reading a table, really. All right, and another one where you could, again, make a bar graph if you wished. I'm not doing that this time. All right, let's just count it. How many trees? It says trees on a plot of land. Here's a list of 10 ash tree heights. How many are over 50 feet tall? So 52, 52, and that's it. Just 2 of them. Just 2 of these trees are over 50 feet tall, right? You don't need to make the bar graph, but you could. Right? It wouldn't hurt to do it. All right, so I got one last objective here. All right. Choose appropriate graphs and charts to display data. All right. Now this is going to be between a bar graph and a pie chart. Now you've probably seen pie charts before. A pie chart looks like a circle and is filled in with little slices that add up to 100%. Right? Pie charts are usually used for percentages and non-overlapping categories. But let's click on more instruction. Bar graphs. All right, so there are many different ways to display data, right? But choosing the most appropriate type of display is important, right? You don't want to deceive people or throw bad graphs at people. Right? Each type of data display shows different data in different ways, and certain ones are more accurate and useful depending on the type of data that's being collected. You've seen bar graphs, right? Bar graphs consist of bars that are separated from each other or connected. You've seen connected ones. The bars can be rectangles or they can be rectangular boxes, used in 3-dimensional plots. And they can be vertical or horizontal. Bar graphs are appropriate for categorical data, right? Qualities, data separated into qualitative categories. And when you want to show the absolute quantity of each category. They are useful for making comparisons between separate subcategories. The bar graph above shows the type of... Alright, okay. You can see that there. Pie charts. Pie charts are a type of graph where a circle is divided into sectors or slices, right, with which each show the proportion or percentage of that subcategory compared to the whole. Right, it's all about percentages in a pie chart. Like bar graphs, pie charts are also good for representing categories, right, categorical data. But unlike bar graphs, all of the data values in a pie chart must fall into just one category. Right? No data value can land in 2 different subcategories. Right? So you can't have a piece of data represented by one slice and another slice. Right? Every piece of data is represented by a single slice. Right? Okay, so here's an example here, right? And they all the percentages should add up to 100%. Right. No, I'm not going to read all of it, but bar graphs versus pie charts. As long as there's no overlap of data values, right? A data value does not fall into 2 different categories. You may use either a bar graph or a pie chart. They're both equally valid, equally appropriate graphs. Keep in mind that a bar graph is more helpful when comparing categories to each other, whereas a pie chart is more helpful when showing a category's proportion to the whole, or a percentage. However, if any data falls into 2 or more categories, then you should use a bar graph. Right? It's not appropriate to use a pie chart. A pie chart with overlapping data can be misleading. Line graphs are useful for representing specific data values over time, as we've seen, right? As time passes, how is the data trending? And yeah, right, so some key terms, you've seen all these before. So now you're just going to be determining what types of graphs are appropriate for what situations. All right, so a question here. The Terman study of the gifted followed children who scored above a certain level on an IQ test into adulthood. The study collected information on the same participants, including the average height of the group, approximately every 5 years. Which of the following could best display how the average height of participant changes over time? There's the key word there, over time. A line graph would be most appropriate in this situation to show how something changes over time. And again, read the explanation. Okay, Deborah conducted a survey in which she collected data on the percentage of workers with college degrees and the percentage of workers without college degrees. Which of the following could sufficiently display the data if only the two given categories are to be included? All right, so percentage of workers with college degrees and the percentage of workers without. Now, those don't overlap. Right? You're not going to have a worker that is both has a college degree and doesn't have a college degree. Right? You're not going to get any overlap here. So both a pie chart or a bar chart would be good. All right? And again, because there's no overlap. And you could use a pie chart too, because either you have a college degree, or you don't, right? So all the percentages will add up to 100%, and they mentioned that here. This implies the percentages must account for 100% of the individuals in the sample. Right. If percentages don't add up to 100, then a pie chart wouldn't be appropriate. Right. Which of the following sets of data should not be displayed with a pie chart? Right. Assume that only the two given categories will be included. Right. So let's see. The percentage of people that own dogs and the percentage of people that own cats. Right there. A person can own a dog and a cat. There's overlap. There's possible overlap here. Remember, pie charts are not appropriate when there's possible overlap between categories. So right away, I'm seeing overlap there, that one. And again, they talk about the overlap and all that down here. Shouldn't use a pie chart. David conducted a survey in which he collected data on the percentage of students that have science majors and the percentage of students that have humanities majors. Which of the following could sufficiently display the data? There's overlap. Students can double major, right? You can have a science major and a humanities major. So a pie chart, again, is not appropriate. Right? Not appropriate. So only a bar graph would be appropriate here. Okay. Well, again, hopefully that makes sense because there's possible overlap between categories. And that's it. All right. So again, a pretty long one. Took a little over an hour, but hopefully you saw it. Now I did get a couple wrong because of the way that remember moving those points around on graphs can be a little sensitive, as you saw with me. So be careful with it. Also, how to read a chart, right? When they talk about totals, right? They didn't put the word total in that one. But hopefully, watching my video here, I'll take you through section 2.1's KnewtonAlta homework and give you a decent guide as to how to get through different types of problems. And I also went over the different instruction and how to do things on your calculator and junk like that. All right. So read the OpenStack section. Practice some stuff there. Watch some videos that were posted in the 2.1 page, the YouTube videos. If you want, take notes on those, and work on the assignment, and click on more instruction whenever you come across a new objective or have a problem struggling with a problem. Now, if you already know how to do things, you don't have to click on more instruction. Right? So hopefully this was helpful. Hopefully all my videos will be reasonably helpful, help you guide you through these assignments. And thank you very much for watching.